So it's audible, Professor, through mic. Yes. Yes. Good afternoon to one and all. Is it audible to Professor? So unmute better.
It's audible, Professor. Shall we start? Can you please switch on your mic, Professor?
Okay, can you see my slides now? Okay, very good. So, very good afternoon, everybody. My name is Mikhail Nik, and I'm very glad to give a talk at your conference. And can you hear me? Please confirm. Can you hear me? Okay, very good, very good. Okay. So I would like to thank the conference organizers for giving me such an invitation to talk to this audience. And I will talk about impurity ions in solids, how you can model their properties theoretically with different methods. So this is my talk outline. So I will start with a brief introduction to highlight the role of defects in inorganic crystals and influence of those defects on their optical properties. I will also then switch to initial calculations of inorganic crystals properties. And I will consider two examples. This will be yttrium aluminum perovskite in its neat or pure form, or doped with cerium 3+ ions, titanium 3+ ions, and with some so-called andesite defects. Then also I will switch to manganese 4+ ions for some materials for lighting. I will give a few examples of crystal field theory, how you can use it to calculate energy levels of impurities in crystals. I also will give some short overview of some mistakes or some improper understanding of our initial calculated results, and I will finish with a set of conclusions. Okay, so then let's now go to defects in inorganic crystals. So as you all know, a unit cell in an ideal crystal, just a moment, yes, just I want to check you, okay. So, an ideal crystal is a repetition of a unit cell in 3 dimensions. So then it is ideally periodical in 3 dimensions. So this is kind of image of this unit cell, which is multiplied in 3 directions. So this is the ideal crystal. But the ideal crystals, in fact, never exist. There are some different defects in these materials, and there is a very nice quote which goes like this, that crystals are like people. It is the defects in them which tend to make them interesting. And in fact, here those defects are responsible for many properties of materials which we are going to use. So this quote is sometimes ascribed either to Sir Frank or to Sir Humphreys. I don't know exactly who was the author, but the quote is really very nice. So what are those defects in inorganic crystals? There are plenty of those defects. So I will give here some examples of few defects which are, let's say, atom-related. So one defect is so-called, one kind of defect is so-called substitutional atom. When an atom of crystal lattice is replaced by an atom of maybe an ion or another chemical element. It also can happen that this another atom occupies a position in between crystal lattice sites. So that is so-called interstitial atom. Or we also can have something what is called vacancy, when the host ion is kicked away for some reasons, and then there is something kind of empty space at the position. And that empty space can attract electrons. So then we can have some electrons which are bound to those vacancies. So these are of course not all types of defects in crystals. I do not touch here dislocations. I do not speak here about surfaces. I speak only and entirely about those defects which can be made by different atoms which can be introduced into crystal lattice. And to highlight the role of those defects in crystals, I give here an example of aluminum oxide, which is also known as the corundum, Al2O3. So if this material does not contain any impurities, it appears to be colorless or maybe somehow gray material in color. But if a few percent or maybe even 0.5% of aluminum ions are replaced by chromium, so then we have a drastic change of appearance. We have a material with either light pink or deep red color, and it is a precious stone which is called ruby, which can be pretty expensive. Another example is the same corundum, but if a few percent of aluminum ions are replaced by titanium, we have another drastic change of color. It becomes to be blue sapphire. So these are kind of classical examples which illustrate what is the role of impurity ions in optical materials. So the key point here is that even a small amount of those impurity ions, as I mentioned, maybe 1%, maybe even 0.5%, can significantly or even drastically modify the optical properties of a crystal. So when we speak about those chemical elements which can be introduced into crystalline solids, they are basically either transition metal or 3D ions, or so-called 4F ions or ions of rare earth elements. So if you think about 3D ions, so the question is what are those elements? So these are metals in the fourth period of periodic element table. They are of course metals, they are very good conductors of heat, electricity. They have this shiny, typical metal appearance. So these are the images which I took from Wikipedia to illustrate that these are all metals: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. And the question is charge, and then because of metals which can be formed, Some of those energy levels can be split in crystal fields, and then we have a bunch of energy levels. Some of those energy levels can be in the material's bandgap, and then optical absorption and emission can take place between those levels of impurity ions. So these are examples of 3D ions, and now so-called 4F ions, or rare earth elements. They have their unfilled 4F electron shell, and they are also metals. They are also good conductors of heat and current. Special care should be taken about this chemical element promethium, because it is radioactive and it is of course not used in optical applications. But all the rest, such as antimony, cerium, praseodymium, neodymium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and lutetium. So these are the atomic numbers given after chemical element symbol. And again, similarly to the case of 3D ions, interaction between unfilled 4F electrons gives rise to a large number of energy levels. And those energy levels can be responsible, and in fact they are responsible indeed, for emission and absorption of light by crystals or glasses or powders which contain those chemical elements. So now I show some examples of ab initio calculations of inorganic crystals properties, and I start with yttrium aluminum perovskite. So this is a unit cell of this yttrium aluminum perovskite. So it has a very wide bandgap, about close to 9 eV, which is good, because then in this case it is possible to introduce different impurity ions which can have many energy levels in the bandgap. So if it is doped with rare earth ions, so then they occupy yttrium site, which is 12-fold coordinated. If this material is doped with manganese ions, for example, so then aluminum ions, so these are black small spheres, so this will be occupied by ions of manganese. So these are details of calculations which I will not go into detail. Okay, the first example is cerium 3+ open, which occupies yttrium site. So this is the bandgap of pure yttrium aluminum perovskite. So in the bandgap we have nothing, as it should be. This is a band-structural ideal crystal. But when we replace one of aluminum ions by cerium 3+ ion, so then we start seeing some states in the bandgap. So these are cerium 4F states, and the point to be mentioned here is that the ground state of cerium in the bandgap is about 3.5 eV above the top of the valence band. Okay, so this is a clear and very good illustration of what happens with the crystal if you have some defects or some impurities. We do have some energy levels in the bandgap. Yes, so this is a manifestation of doping effects on the host crystal's electronic and optical properties. Well, so as I mentioned, cerium 4F states are in the bandgap. So this result which we obtained, about 3.5 eV, is in a very good agreement with estimations from the empirical model which was developed by Professor Peter Doornbos. So it is again a nice illustration of how theory and experiment can agree with each other. And what I show here in this panel is the experimental absorption for F5D spectrum of cerium 3+ ions in this material. So this line is spectrum absorption, and these 5 vertical lines are the calculated energy levels, 5D levels of cerium 3+, which were obtained by crystal field calculations. So as you see, we have good agreement with splitting of 5D states and experimental shape of the spectrum absorption its broadness and the position of the maximum. And in this slide, I show how you can combine together the crystal field theory, which gave us the 5D states of cerium C+, and their splitting, and DFT theory, which gave us this estimation of the ground state of cerium forest levels in the band gap. So what I do now, I simply plot the ground state of cerium at 3.5 eV above the valence band top, and then from this 4F ground state, I plot the 5D levels which I calculate from crystal field theory. And now we can see that some levels, higher levels of cerium, they fall into the conduction band, but the lowest 5D states, they are still below the conduction band, which means they can be seen in the emission spectra, and indeed this material is known for bright cerium 3+5D 4F emission. Okay, what also may happen in this material, so-called anti-side effects, when these two cations, lithium and aluminum, interchange their positions. So what we have done is as follows. We, in a unit cell, we swap the lithium and aluminum positions for a couple of lines, and then we calculate the band structure. And we start seeing empty yttrium 4D levels, but those levels of yttrium which are at the aluminum side. So then when we look at the density state diagrams, so here this black line are yttrium 4D levels for true yttrium side, and these red dashed lines are the 4D levels of yttrium for yttrium and aluminum side. And the difference here is about 0.9, close to 0.9 eV, which shows the energy, or the depth of the trap of energy of excitation. So this result can be checked by the experiments on thermoluminescence. With increase of temperature, at some temperature, we can transfer the energy of excitation from 4D states here to the conduction band, and then we can have this band-to-band emission. Okay, what else? Now the same material but with different, let's say, defects with vacancy. So we simply remove one oxygen ion, with additions of titanium C+ or titanium 2+ instead of aluminum ions. So these are the unit cells which we have plotted for these materials. So what is going on here? We show the, okay, first of all, it is possible after DFT calculations to optimize geometry and see what are local deformations around different defects. So we see the incorporation of titanium ions. They produce some modifications of chemical bonds. It is also possible to estimate the positions of 3D levels of titanium 3+ in the band gap, because titanium 3+ has a single d electron, and those d orbitals are split into so-called T2G and EG states. So now we can get here this estimation of ground state above the valence band top. We can have estimation of this splitting here, 10dq, which here appears to be about 1 electron volt. Yeah, and this is also important for understanding of impurity properties in solids. So when we have a vacancy which then can attract an electron, we have what is called the F center in this material, and the energy level of the F center is about 3.36 eV above the top of the valence band. So no matter what kind of defects we have, it is always possible to estimate their energy positions in the band gap of the host material. So here we have this kind of combination of altogether, in this case, K.B.N. 2+, which has D2 configuration, so different states here, and all of them are plotted against the top of the valence band. Okay, and now I switch to another example, manganese 4+ ions for phosphor materials. Okay, so it's very important to have good white LEDs, we know this. So this is the spectrum of first white LEDs, which were composed of gallium nitride blue LED, and which was covered by lithium aluminum garnet powder with 73+. So this phosphor material can absorb blue light of blue LED and convert it into yellow light. So then blue light and yellow light altogether gives us white light. But this white light does not have, let's say, very good properties. It appears to be cold light, which is not so good for human eyes for living interiors. But it has been noticed somehow that addition of red emission to the spectrum can improve considerably the properties of this white light. And then very good emitter for this purpose is manganese 4+, because it can absorb blue light and can convert it into red light. So then we can have gallium nitride blue LED, which is covered by a mixture of two phosphor materials, this CMC plus lithium aluminum garnet, and some phosphor material with manganese 4+. So then altogether blue, yellow, and red would give us good white color. So here I show the energy levels of manganese 4+ as follows from Tanaka-Sugano diagram. So this very efficient excitation for a 242 transition, about 450 nanometers, and this is not the case with the both lines. The emission, which, okay, this excitation is accompanied by the non-radiative relaxation and spin forbidden 2E for a 2 emission, which is very sharp because it is spin forbidden, and it is possible to shift this emission in a wide range. Here I have to emphasize the possibility of such shift can be realized not in the same material, but if we simply use different phosphor materials. So in fluorides it is about 620 nanometers, in oxides it is redshifted all the way down to even near infrared. So with this impurity, manganese 4+, it is possible to cover a wide range of red emission here. So some time back, with my good colleagues and collaborators from the USA and from Poland, we published a couple of review papers in which we were able to find out some systematic trends in behavior of manganese 4+ ions in solids. So this is just, let's say, title of one paper, and also one more paper was published in Chinese Journal of Luminescence. Here I will not go into the details of these review papers which you can find. I would like to turn to examples of an initial analysis of properties of impurity ions in these materials. So the first example is these so-called hexafluorosilicates. So here the first cation A can be either potassium or rubidium or cesium. And the incorporation of manganese 4+ leads to the replacement of silicon, which also has a charge 4+, by manganese 4+. And here are some results which we obtained. So we just replace in the unit cell silicon by manganese. So then, of course, the optimal geometry, addition of manganese also does produce some variation of chemical bonds. It is clear why, because manganese 4+ has a larger ion radius when compared to the silicon 4+ ion radius, so we have kind of expansion of crystal lattice. which is shown here by these numbers. But the point is again, if you look at the density of state diagrams, for a pure material, for pure horse, we have nothing in the band gap. But for manganese for plus ions, you have extra states in the band gap, which are again T2G and EG states spin up, and T2G, EG states spin down. And when we analyze these states, so this distance from T2G spin up to EG spin up gives us crystal field strength 10 dq parameter. And the distance from T2G spin up to T2G spin down can give us an estimation of this spin fleet transition to E4A2. So here we have these numbers which we calculate, so 10 dq, and the energy of this to E4A2 emission. So we do not get exact correspondence with experimental data, and I will tell you why later on. But what is essential, when we can reproduce the experimental trend in the behavior of 10 dq and the emission energy. Look, when we move from potassium to rubidium to cesium, we have a decrease of 10 dq, which is also confirmed by calculations. And we also have a red shift of 2E4A2 emission, which is also found in our calculations. So we can at least reproduce the trend in the behavior of the main spectral properties. So if this again enlarged view of these density of state diagrams with those indications T2G, EG levels, and now I'm going to explain at least briefly why we do not get exact correspondence with external data. Okay, this is because of certain limitations of DFT theory. So these are the possible configurations of D3 configuration in crystal field. So we can have T2G spin up 3 electrons, T2G, EG spin up, all the electrons are here. We can have 2 electrons in EG states, and we can have here spin up, spin down states in EG states. And then what is going on? If we speak about this spin fleet transition, so an essential feature here is it should include the spin orbit interaction. And now what is going on? Now I analyze in some details this T2G spin up 3 times, T2G spin up 2 times, T2G spin down 1 time. So then we have here a number of states. So here for A to G state for the ground state, and for this configuration of this excitation or spin down, we have 3 possible states: 2EG, which is in fact level of emission, 2T1G, 2T2G. But if you take into account orbit coupling, these states 2T1, 2T2 will be split into gamma 6, gamma 8, gamma 7, gamma 8. So these are irreducible representations of the double or H double group. And look, we have here gamma 8 state in the ground state, and in all 3 higher energy levels. So we have a mixture of states, and this effects of mixture, they should be considered, but still it is beyond the simple approximation of DFT calculations. A good point here is that we can handle in a good way those impurity ions which are single electron, like I have shown you previously, cerium 3+ or titanium 3+. Because in this case we have no effects of multi-electron interaction. Okay, one more example here. The same potassium hexafluorosilicate with manganese 4+. So here what we could have done, we could optimize geometry of manganese F6 complex in different states, in the ground state for A2, in the 2 heavy states, 2E here and 42 here. So then we also can see how the geometry is somehow changed because of electron excitation and because of interaction of electrons with ligands. So this is, we have kind of tetragonal deformation which is explained by the Young-Taylor effect in the United States. So this is also an example of how we can get a handle on the Young-Taylor effect for 3D ions. Okay, a few examples about crystal field calculations. So these are empirical or semi-empirical calculations. Crystal field results cannot give us the band structure, but what they can give us is that they can give us a proper description of splitting of multi-electron states. And here I show the spectra of manganese in 3 peroxides here with Ln being either yttrium or gadolinium or lanthanum. So these are data of non-crystal structure of these materials. One is cubic, one is tetragonal, one is monoclinic. Okay, so these are the images of unit cells of these crystals. In all materials, manganese 4 plus occupy the sites of niobium and B5 plus. So these are the heteroid which I highlight for different perovskites we use. Okay, and then here I simply show the set of equations which have been used in the framework of so-called exchange charge model of crystal field. I will not go into details, but just mention that, okay, if we know the structure of the material, we can do this. We can get the structure from X-ray diffraction, from X-ray data. So then we can calculate these so-called parameters of crystal field here, which also include overlap integrals between D ions of impurity and S and P functions of ligands, and then altogether we can find out the eigenvalues of this crystal field Hamiltonian and get energy levels of impurity. Okay, so here are the results for all those 3 perovskites we considered. So the blue lines are the spectra of excitation, red lines are emission, speed forbidden sharp emission of manganese 4 plus, and those vertical lines are calculated energy levels, which were obtained by crystal field calculations. And as we can see, we have a good agreement with, between energy levels positions and main features of spectrum shown in these diagrams. So this is what cannot be obtained by DFT, but this is what is extremely important for proper description of impurity ion properties in crystals. Okay, now I'd like to touch briefly some very important things which get overlooked sometimes. Some mistakes which people do when they analyze the results of their calculations. So nowadays there are many different DFT-based programs which are widely used. Some of them are commercial, some of them are not free for users. Some of them have rather easy run-and-go interface, so quite a number of groups use these calculations, but there are so many mistakes, so many inaccuracies which are reproduced from paper to paper, and then they become kind of, and they put this in quotation marks, they become kind of truths because they are published and republished again and again, and somehow we have to understand what is wrong there. So here I show some examples. Okay, band gap calculations. People often forget that DFT cannot handle band gap properly. We always have underestimation of the band gap. And the underestimation can be sometimes half EV, maybe 1 EV, and then, for example, what can be made in papers. Okay, people write just an example. For something conductor, you have 1.12 EV band gap, which is close to silicon, and then it can be used in some materials instead of silicon. And this is wrong. And why? Because the true band gap will be about at least 1.5 EV greater. So then this material will absorb not infrared light, but kind of blue light or even UV light. Then also people do not pay attention to the fact that if they calculate spectral absorption, it is possible to do in DFT, so the intensities, they depend very much on the basis set, on the settings of computations and so on. So then, for example, they also can write that the semiconductor under consideration is an efficient absorber in the infrared and visible spectral range. Yes, it is also wrong because there is no comparison with other materials. Even if the results can be very much software dependent, at least if the comparison of different materials whose properties were obtained in a systematic way in the same framework should be done, only then we can come to some kind of conclusions. So, like for example, here it is a graph from one of my old papers where I compared the absorption density of four or five here materials. Then if I compare these peaks here, I can say, okay, this, let's say, kind of pink line, which has this composition, is kind of effective or efficient absorber in this part of the spectrum, if compared to other spectrum. Okay, so also people often do not pay attention to the effects of chemical bond formation and effects of hybridizations. So often they write the conduction band, as example, is made by the two pieces of oxygen. This is ultimately wrong. Why? Because two pieces of oxygen, they correspond to the completely filled orbitals and they are in the valence band. Yet, some contribution of two pieces to the conduction band can be seen. Why? Here I show an example of cadmium iodide with nickel 2 plus, and nickel 2 plus has, of course, effects in the valence band, but also something in the conduction band. How can it come? Well, because of hybridization, because of chemical bond formation between nickel and iodine. And these are density of states of 3D orbitals. And look, even there is some kind of non-zero 3D character of atoms or iodine ions. Because of overlap of 3D states of nickel and 5s states of iodine. So in this case, yes, we can say that there is a very minor contribution to the conduction band by iodine, 5p states, but this is by no means the main contribution. It is a very tiny one, a very small one because of hybridization, and the main contribution is made with the valence band here. What also can be important, since the band gap is underestimated by DFT, sometimes, okay, one more point. People simply give very wrong statements. If they calculate the band gap of impurity with impurity, so then some softwares like Castle, for example, automatically give band gap as a difference between the valence band and the first unoccupied state. But they still is a first unoccupied state of impurity. The true band gap is not modified if you introduce a small amount of impurity, about 1%. You simply produce the localized states in the band gap. So then again, the band gap is not modified, is not decreased by 1% of impurity. You simply have here the impurity states, and the band gap is still the difference between the conduction and the valence bands. One more point which is important. As I mentioned to you, the band gap is always underestimated. So then it may happen that the unoccupied states of impurity will end up, because of underestimation, in the conduction band. And then they have seen such papers a few times, then people make a conclusion, okay, now we have a conductor because it has a zero band gap, which is given by this erroneous underestimation of the band gap. And of course, it was not possible to convert insulator with wide band gap into a conductor by doping only with 2% of purity. So again, an utmost care should be taken when people look at the results of DFT-based calculations. Always people should pay utmost attention to those things. Okay, now maybe I try somehow to make conclusions, okay? So DFT methods, which I just touched briefly, very briefly of course, they appear to be extremely powerful tools to calculate various properties of crystals such as structural, optical, electronic, and so on. If we combine together DFT and crystal field approaches, we can get what I call a complementary picture of optical properties of crystalline solid series impurities. And as I emphasized, a lot of attention should be paid to the proper analysis of DFT-based calculations results in order to avoid mistakes and wrong interpretations. I would like to acknowledge my good friends and colleagues in different places of the globe. And of course, I thank you for your attention. And if there are some questions, I would be happy to answer. Thank you so much. Do you have any questions?
Yes, Professor. It's a nice talk. It's a nice talk on impurity ions in solids, theoretical and modeling of optical properties. So this was nice talk to impurity of ions in solids, theoretical modeling of optical properties is mainly defined as role of defects in inorganic crystallines in formation of their optical properties, and the talk is mainly focused on inorganic crystal lattices, like different kinds of defects in inorganic crystals, substitutional and interstitial atoms like aluminum oxide, chromium, and aluminum and titanium, and also focused on lithium boron ions, getting the blue LEDs and white LEDs. So it was nice talk, and it is useful to the MSc students and research scholars. So any queries in this session?
Hello, Professor Brick.
Hello, great to see you again.
Thank you.
Great to see you.
Maybe after 10 years.
Yeah.
On the behalf of all our students, we thank you very much for the nice talk.
My pleasure.
It's a wonderful talk. We have enlightened all the possibilities of our mistakes in calculating the band gaps and all. It's an excellent talk, and we are all benefited with your talk. Thank you very much for accepting the invitation and giving the excellent talk. Thank you.
Thank you so much.
is Rohita, research scholar from National Institute of Technology, Warangal. So the talk is wonderful, sir. The main striking is like you are involving the things, the way you present is innovative. Like it is engaging, like how you have written like calculation error. That is wrong, this is right. That itself brings the attention of the audience towards your topic. It is great that I have listened to your topic, sir. Thank you.
Thank you.
Anyone?
Good afternoon, Professor.
Good afternoon.
Sir, it's my honor to thank you, sir. So, in order to publish one of my paper based on Chromium, I referred your paper, and because of that, your article only, I gained a lot of information that helped me publish one of my papers, sir. Thanks for giving me the opportunity, sir. Thank you.
Thank you.
Thank you, Professor. Actually, Professor Brick awarded a PhD degree from K.B.N State University, Russia in 1995. And his habitation degree means research and academician's provisions. So from Institute of Physics, Polish Academy of Sciences in 2012. He has more than 20 years of international scientific career in Eritrea, Israel, Japan, Estonia, Poland, China, Serbia, etc. And research interests of Professor Brick are focused on first principles and semi-empirical calculations of various properties of optical materials doped with transition metals and rare earth ions. And he has active collaboration with many academic and institute research group of Europe, Asia, USA. And also he is a special issue editor of Optical Materials. He is a journal, foreign member of Latvian Academy of Sciences, honorary member of Academy of Romanian Scientists. And also, Professor Brick has received several prestigious awards. The Dragomir Hrumasic Award from the Romanian Academy of 2006. The Estonia State Prize in Exact Sciences in 2013. The Chinese Government Friendship Award. Chinese Government Friendship Award in 2022, the Luminescence and Materials Division Sentinel Outstanding Achievement Award from the Electrochemical Society 2024. Also, according to Google Scholar, Professor Brick has more than 17,100 citations and H-index is 66. It's a great honor to Professor to read your CV, and thank you very much. Our prestigious, it was a great talk.
Thank you very much.
Yeah, all of you give a standing ovation to Professor.
Thank you very much indeed.
Thank you, Professor.
Thank you.
Yeah.
All the best.
Yeah, we'll meet.
Bye-bye.
Thank you.
Have a good day. Bye.
Bye, Professor. Thank you. Dear students and faculties, one of the oral presentation, that is DS Rohita from NIT Warangal. I welcome to her to give a oral presentation on her talk. Please.
Shyam Prasad sir from Department of Physics, NIT Warangal. Today I am going to give a talk about my research work, which is design and development of phosphate-based glasses and glass ceramics for tissue engineering. Before going into the topic, let us see the outline of our presentation, comprising of, I'm going to introduce the layout or the background of my work, then followed by laying the objectives through identifying the research gaps by literature survey, and I'm going to explain the methodology which I opted to satisfy my objectives, followed by discussing the results which I have obtained and the conclusions which I have obtained by the results, and how the conclusions have laid a new path for my future work. So, my title itself is saying that phosphate-based bioactive glasses. What are bioactive glasses? The word bio itself says life. The glasses are something which we see in our daily life. The glasses, when they are incorporated in the live persons, like whether it is animals or it is human beings. There are very less studies which state about plants, so let us consider both animals and humans. The glasses which can be incorporated with body of the living organisms. That means they should be having some bioactivity nature. What is bioactivity? The bioactive glasses are a kind of biomaterials. We are a form of biomaterials. What are biomaterials? Biomaterials are the materials which can be incorporated within the body cells, within the body, in the living tissues. Then, after incorporating, they should not cause any harm to the other living organisms. That means this should not cause any toxicity. At the same time, they should be biocompatible. Compatibility. That means it should be it is the guest and it should accept whatever host is giving. And it should be compatible with the host. The guest should be compatible with the host. That means it should not create any problem to the host. And it should be doing its own work by creating no problem to the host materials. So they should be biocompatible, they are bioactive, and they have properties such as angiogenesis. Angiogenesis is a term which says about the blood vessels. Yes, formation of blood vessels. It has a property such as formation of blood vessels, and they are anti-inflammatory. Anti-inflammatory in the sense they does not cause any much damage to our cells when they are incorporated within the body. Also, they are antibacterial in nature. That means there is no cause of future problems because of they are antibacterial. And they promote osteogenesis. Osteogenesis is a term, yes. It represents the cell proliferation will happen such that the bone will, which is used for the new bone cells to participate, such that that will just the promotion of the cells during the bone disturbance when they are being incorporated in the host when they are affected with some or the other fractures. So the properties are framed in this, and they have, because of their properties, they are being used in several applications such as dental, cardiovascular, drug delivery, antimicrobial, and orthopedics. These bioactive glasses, they have to be made with a glass formers. So the main three major glass formers are silicate, borate, and phosphate. They are the glass formers. And when the glass formers are being added with the glass modifiers, then a complete bioactive glass is formed, through which we can alter what is the necessary thing which we need that can be altered with the help of modifiers when they are added to our glass formers.
we have silicate basic glasses, borate basic glasses, phosphate basic glasses, each of them having several advantages as well as several limitations. We can alter the limitations according to our need by adding the modifiers or actinides, lanthanides, also rare earth materials, each of them having the specific application-oriented targets. So, we are known about silicate, borate and phosphate. In my work, I have chosen phosphate basic glasses because phosphate basic glasses have superior bioactivity and bone healing capacity when compared to silicate and borate basic glasses, because phosphate basic glasses already consisting of the phosphate element, which is highly beneficial for our bone healing materials. Our bone is made up of hydroxyapatite layer, which is comprising of both calcium and phosphate. So our phosphate is already consisting of phosphate. That's why they exhibit superior bioactivity and bone healing capacity. And they have undergone more rapid degradation. Rapid degradation, it means that whenever they are being incorporated in our body, it will degrade so fast. So our application should be oriented on that such that it will degrade fast. Or we have to add something to it so that we can increase its degradability, to decrease its degradability according to the application which we want. So the degradation, and it can be converted into HAP layers so fast when compared to silicate and borate basic glasses. When compared to silicate basic glasses and borate basic glasses, for any glass to form, we have to do the calcination procedure. So for the calcination procedure, silicate basic glasses will get calcinated at 600 degrees Celsius, whereas borate basic glasses will get calcinated at 550 degrees Celsius glasses. But our phosphate basic bioactive glasses, since they have very low melting point, it gets calcinated at 300 degrees Celsius, sometimes at 250 degrees Celsius also. So that is the benefit of our phosphate basic glasses, and they are non-corrosive in nature. When lanthanides and actinides are added to the phosphate basic glasses, they tend to form complex, they tend to make complex strongly with our glasses. When the phosphate basic glasses are being doped with lithium, they increase the tissue response. The cell tissue response has been increased. This is these are the points which I have gone through literature survey, and by undergoing some literature survey and identifying the research gaps, I have laid the objectives by synthesizing of phosphate basic glasses PBG and phosphate basic bioactive glass ceramics, because as we have shown in the previous slide that they are more rapid degradation. When phosphate basic glasses are being converted into phosphate basic glass ceramics, the degradation rate has been reduced. Also, when the glasses are converted into glass ceramics, the mechanical properties of it increases. But so far, the literature have shown that whenever the glasses have been converted to glass ceramics, the bioactivity nature of the glass ceramics reduces. So that is the reason why I took the unique composition stating that when the bioactive glasses are being converted to glass ceramics, they are showing bioactivity, they are showing more degradation, less degradation rate, and they have more mechanical strength. I'm going to synthesize PBG and PBGCs, and I'm going to study the in vitro bioactivity. Also, the structural analysis have to be done, and the cytotoxicity percentage is to be calculated. These are my prime objectives. To synthesize PBG and PBGC's classes, the methodology which I have opted is Sol-gel technique, in which I took only the nitrates by adding triethyl phosphate with ethanol, titanium isopropoxide, ethanol plus calcium nitrate, lithium nitrate and vitreous nitrate with ethanol. All of them are being diluted in ethanol with 1:3 ratios, and then all the precursors have been added at several interval of times so that we will get a precursor, so that we will get the solvent solution, and we will leave the solvent solution at the room temperature for 2 days. Later, that is the solution is been centrifuged. The centrifugation will give us the powders. The powders are then being kept under oven so that the powder will get dry, and that powder after grinding are being placed in the muffle furnace at different temperatures. As I already told, phosphate based bioactive glasses have less melting point. That means they need less calcination temperature. So I prepared the glasses at 300 degrees Celsius and I got the calcinated PBG powder. I acquired the powder. Now I have to study how they are going to be when I incorporate them into the body. We know what is SPF. SPF is a simulated body fluid. This simulated body fluid is nothing but we have body plasma inside our body. So that body plasma is comprising of a composition. That particular composition is similar to the composition of the SPF solution. That body plasma is also having the same composition as the elements which are present in the tabular form. With the help of these chemicals, we are forming the SPF solution by maintaining its pH at 7.4, which is our body fluid pH value. And we are going to store the SPF solution in our BOD incubator. What is BOD incubator? BOD incubator, in which the temperature is maintained as 37 degrees Celsius. That means within our body the temperature is 37 degrees Celsius. So we have to test our samples at that particular temperature when they are being soaked in SPF solution. Once the soaking is done, we are going to study how the glasses are being reacting with our bodily fluids by doing several other characterizations. That's how I am going to discuss about my results. Before soaking the glass powders, before soaking into the SPF solution, the structural, the morphology of the glasses are been identified in the first line, where 300 is my PBG glass, followed by 550 is just forming the ceramic nature, and the ceramic nature has been increasing as the crystallinity of the glasses will get increased. The morphological studies, it is similar to the spherical image, and the particle sizes are around 150 nanometers. So, and this is the IDAX, which confirms the elemental analysis which are present elements of the glasses. Phosphate, calcium, titanium, bismuth. Lithium is not available because we can't see the elements which are having atomic number less than 5 in IDAX. So after soaking in SPF, after 14 days, I have observed structural changes, like morphological changes, like the sphericals are being formed with the layer of HAP layer. It is called HAP layer. I have identified at different temperatures for 300 degrees, for 550 degrees, for 600 degrees, 650 and 700. Over all these samples, I have seen that 600 degrees Celsius is showing a different morphological study whose surface area is different from all others when they are being calcinated. They are having a needle-like structure which is a form of flower. It's like a star ball. So it is little beneficial when compared to other when we are going it for the drug delivery. More surface area takes more powder, more surface area shows more bioactivity. So overall this composition, I have come to a conclusion that 600 is showing a better surface morphology. And the elemental analysis also confirmed the elements which are present in my composition. And these are the XRD before and after soaking in the SPF solution. The XRD peaks also show the hydroxyapatite peaks like 211 and 300 HK values of hydroxyapatite layer. And for different temperatures, 300, 550, 600, 650 and 700. We have identified the hydroxyapatite layer peaks present in our sample. We have performed FTIR analysis for our glasses, says whether the whether the bonds of the hydroxyapatite layer are present or not. Before soaking, we have phosphate bonds, carbonate bonds, because we are already doing with phosphate basic glasses. And the double peak itself represents the hydroxyapatite layer formation, stating that HAP layer bonds, POP bonds, PO3 bonds, and carboxyl bonds are also present, which states that HAP layer formation is confirmed. And this is the pH analysis of the samples. Also, this is a surface area analysis. Though my surface area analysis is showing less result, like they are non-porous, when I confirmed with the BET, I still have to do it with after soaking samples. Here, the better surface area is shown by glass as well as 600 degrees Celsius glass ceramic. This is the inhibition of hemolysis. Lysis itself states like to what extent it has been toxicated. Like this is our red blood cells and this is our negative solution, which is of PBS solution. So when the blood and PBS solution are being added to our 1 gram, like 5 mg sample, we are adding 1 ml of blood as well as PBS solution, and they are being kept under rest, and then they are being centrifuged. After centrifugation, if the blood sample is added as a layer over top of our powder, then it says that our powder is non-toxic in nature. That means its lysis percentage is less, which has been identified. We took the UV of this, and then through UV we find out we have framed the graph which states that the lysis percentage is less than 5. So all our samples are showing very less hemolysis, less than 5%. We have identified that the percentage level is above 70 degrees Celsius, above 70% of cell viability, states that it is non-toxic in nature. Also, some of the samples have crossed 100. That means they are showing more biocompatibility. After 24, when it comes to 72 hours, the higher rate of cell viability is shown by phosphate basic glasses ceramics at 600 degrees Celsius. So with this I conclude that I have obtained the desirable glass samples whose bioactivity and morphological studies were identified by XRD, FSM and FTIR and IDAX. And I have also obtained the hydroxyapatite peaks and bonds through the characterizations, and I have also obtained the PBG and PBGCs are not causing any excessive hemolysis, and I have also obtained the best biocompatibility and cell proliferation results for all the samples when they are tested with cell culture and migration assay. Obtained that PBGC glass ceramic at 600 sample as the best sample among all the samples when it is comparable with all the characterizations. With this, I am going to lay a new foundation for my future work, as when the bioactive glasses are combined with the polymers, they lay new properties. We have seen the bioactive glasses properties, and we will be knowing about polymer. Polymers have mechanical strength, more mechanical strength, and they are printable, and they are biocompatible as our bioactive glasses. So when bioactive glasses are combined with a polymer solution, that lays a new study. So my future work is to develop multifunctional biocomposite hydrogels by adding natural polymers to our bioactive glasses. I have already prepared few tests. I'm doing few tests on hydrogels. Like when bioactive glasses are added with polymer, along with the cross linkers, a hydrogel is formed. Once after freeze drying it, I have obtained a more porous kind of scaffold kind of thing, which after doing this, FSM results are showing that these are the bioactive glasses holded by the polymer, whose IDAX is showing the results of our glasses. The glass composition is being holded by the polymer, showing that the elemental analysis like bismuth, titanium, calcium, phosphate, and all the components of our glass are present. So further I am going to study more about the hydrogels, and I am going to alter the compositions with other polymers, adding natural and artificial polymers, and then to lay new application oriented work. Thank you.
Congratulations. It's a nice talk.
Thank you.
So I appreciate your communication skills and presentation skills. But I have a suggestion if you accept.
Yes, sir.
You are not independent researcher, right? You are working under a supervisor.
Yes,
As
sir.
a scientific group you are working.
Yes, sir.
So generally, I am presenting on behalf of is okay. But when you are presenting your research studies, you should not use I observed.
Yes.
We, our study shows.
Yes, sir.
That adds more humbleness to your presentation, right?
Sure, sir.
Okay.
Yes.
That's only my correction. Okay.
Thank you, sir. Students are open to communicate with the doubts or questions. Yes.
Firstly, thanks for giving this nice presentation, and I would like to know more about EDAX.
EDAX.
Yeah.
Okay, EDAX is supposing here the precursors which I have used is having elements. Like in PEP we have phosphate. This is having titanium. This is having calcium, lithium and bismuth. So we have the elements around 5. 1, 2, 3, 4, 5. We have 5 elements. So after doing the FSM analysis, this will concentrate at one particular state, and that will give what are the components which are present in that particular area. So the components means the elements which we have added. The 5 elements. The 5 elements will be identified by the elemental analysis thing. So all the 5 should be present here, including lithium. But lithium, since it is atomic number is less than 5, it can't be identified by EDAX. Rest all are already present.
One more question, that is, you told before that your phosphate glass, bioactive glasses, having less melting point,
Yes.
and it is observes the calcination process at 300 or 250.
Yes.
But overall presentation doesn't explain about 300 and 250.
I do explain about 300 in the flow, but you have listened more about 600, 650 and all.
Yeah.
Because before the study, before the presentation itself, I told that I want to increase the bioactivity nature by increasing the mechanical properties. So the ceramic will not have more bioactivity when compared to the glasses. Recently the studies are showing more bioactivity when we are using a certain composition. So my composition itself is responsible enough to make me go through 600. Thank you.
మాట్లాడమన్నాను మేడం దీని మీద. Dear students, please maintain silence. The validity session will start within few minutes. Please. Good evening to all the esteemed dignitaries, distinguished guests, respected faculty members, and my dear participants and students. It is my great pleasure to welcome you all for this valedictory session of this two-day international conference on functional and smart materials, organized by the Department of Physics, Chemistry, and Electronics in collaboration with the APSHI. Over the past 2 days, we have had opportunity to witness thought-provoking presentations, engaging discussions, and cutting-edge research. This conference has truly been a celebration of knowledge and innovation. Firstly, I would take great pleasure in inviting the principal of K.B.N. College, Dr. G. Krishnaveni ma'am, to come on to the dais. Thank you, ma'am. Now I take great pleasure in inviting the Administrative Officer of SKPVV Group of Institutions, Dr. V. Narayana sir, to grace the dais. Now it's my honor to invite our chief guest for this valedictory session, Professor Y. Srinivas Rao sir from the Department of Electronics and Telecommunication Engineering, Dr. Sardar Patel Institute of Technology, Mumbai, to grace the dais. Thank you, sir. Furthermore, I would like to invite the convener of this two-day international conference, Dr. V. Ravikumar sir, to grace the dais. Thank you, sir. I would like to invite the organizing secretary of the conference, Dr. K. Kiran Kumar sir, to grace the dais. I would like to invite the head of the Department of Chemistry, Dr. O. Sailaja ma'am, to come on to the dais. I would like to invite the head of the Department of Physics and Electronics, Shri R. Uday Kumar sir, to come on to the dais. We thank you for your esteemed presence, for being a part of this event, and we are looking forward to hear valuable words to conclude the wonderful conference. Thank you. Now I hand over the session to the principal of K.B.N. College, Dr. G. Krishnaveni ma'am.
Respected dignitaries on the dais and off the dais, my dear student participants, learned colleagues, good evening to one and all. So, ఈ 2 days technical sessions ki distinct personalities వచ్చారండి యాక్చువల్గా. I think yesterday 3 eminent personalities వచ్చారు. నిన్న మార్నింగ్ ప్రొఫెసర్ బిఎల్వి ప్రసాద్ గారు, డైరెక్టర్ సెంటర్ ఫర్ నానో అండ్ సాఫ్ట్ మ్యాటర్ సైన్సెస్, అలాగే ఈశ్వర్ ప్రసాద్ గారు, సుబ్రహ్మణ్యం గారు కానీ, అలాగే ఈరోజు వచ్చిన శ్రీనివాసరావు గారు. సో దీస్ ఆర్ ఆల్ eminent personalities and we are very lucky to have them. So once again, I thank the research persons who came over here to address our students. Thank you once again. And the main aim of object of organizing this program is actually nowadays artificial intelligence మీద ఎక్కువగా ముందుకు వెళ్తున్నారండి. ఆర్టిఫిషియల్ ఇంటెలిజెన్స్, చాట్ జీపీటీ ఇవన్నీ బాగా వినే ఉంటారు స్టూడెంట్స్. ఎంతసేపు కంప్యూటర్ సైన్స్, ఆర్టిఫిషియల్ ఇంటెలిజెన్స్. బట్ బిహైండ్ దట్ ఆర్టిఫిషియల్ ఇంటెలిజెన్స్కి వెళ్ళాలి, ఒక సిస్టమ్ని ఆపరేట్ చేయాలి, లేదా ఒక స్మార్ట్ ఫోన్ని ఆపరేట్ చేయాలి అంటే బిహైండ్ దట్ ఉన్నది ఏంటి? ఏంటండి అవి? స్మార్ట్ మెటీరియల్స్, సైన్స్. వితౌట్ సైన్స్ దెర్ ఈస్ నో పాసిబిలిటీ ఆఫ్ ఆర్టిఫిషియల్ ఇంటెలిజెన్స్. సైన్స్ కావాలి అంటే ఎక్కడి నుంచి వస్తుంది? ఆర్టిఫిషియల్ ఇంటెలిజెన్స్ ద్వారా సైన్స్ వస్తుందా? మ్యాన్ పవర్, ఖచ్చితంగా మ్యాన్ పవర్ని యూజ్ చేసుకుంటేనే సైన్స్ అనేది డెవలప్ అవుతుంది. సైన్స్ డెవలప్ అయితేనే ఆర్టిఫిషియల్ ఇంటెలిజెన్స్ డెవలప్ అవుతుంది. వితౌట్ సైన్స్ దెర్ ఈస్ నో ఆర్టిఫిషియల్ ఇంటెలిజెన్స్. అంటే యాజ్ అ సైన్స్ ఫ్యాకల్టీగా నేను చెప్పడం కాదు, టు బి ఫ్రాంక్ చెప్తున్నాను ఇది. సో దీని మీద రీసెర్చర్స్ ఎంత వర్క్ చేసి ఎంత డెవలప్మెంట్స్ ఇస్తే కానీ ఆ స్మార్ట్ మెటీరియల్స్ అనేవి రెడీ అవ్వాలి. ఫంక్షనల్ మెటీరియల్స్ ఆర్ స్మార్ట్ మెటీరియల్స్. సో వాటి నుంచే కదా మనకి ఏ కాంపోనెంట్స్ రెడీ అయితేనే కదా వాటి నుంచే మనకి సిస్టమ్స్ కానీ ఇవన్నీ తయారవుతాయి ఈ ఫంక్షనల్ మెటీరియల్స్ బేస్ చేసుకొని. సో వాటి నుంచి అప్పుడు ఆర్టిఫిషియల్ ఇంటెలిజెన్స్ మనం ఉపయోగించగలుగుతున్నాం. అంటే దట్ ఈస్ ద ఇంపార్టెన్స్ ఆఫ్ సైన్స్. సో ఇది స్టూడెంట్కి తెలియాలి. మెయిన్ ఫంక్షనల్ మెటీరియల్స్ ఆర్ స్మార్ట్ మెటీరియల్స్ అనేది మేము ఎందుకు ముందు చూస్ చేసుకున్నాం ఈ టాపిక్. మా కన్వీనర్ గారు వచ్చి ఒక 2-3 టైటిల్స్ చెప్పినప్పుడు నేను ఫస్ట్ దీన్ని అట్రాక్ట్ అయ్యా. ఎందుకంటే దీని ఇంపార్టెన్స్ తెలియాలి, ఎస్పెషల్లీ బికాస్ ఇట్ ఈస్ అలైడ్ విత్ ఆర్టిఫిషియల్ ఇంటెలిజెన్స్. సో దానికి ఎంత ఇంపార్టెన్స్ ఉందో దాని ఇంపార్టెన్స్కి బిహైండ్ ద స్క్రీన్ ఫంక్షనల్ అండ్ స్మార్ట్ మెటీరియల్స్కి అంత ఇంపార్టెన్స్ ఉందండి. సో దీని గురించి స్టూడెంట్కి తెలిస్తేనే సైన్స్ వాల్యూ, బేసిక్ సైన్సెస్ వాల్యూ తెలుస్తుంది. ఒక కెమిస్ట్రీ అంటే ఏంటి, ఒక ఫిజిక్స్ అంటే ఏంటి, ఒక ఎలక్ట్రానిక్స్ అంటే ఏంటి, వాటికి బయట ఎలా ఉంది రీసెర్చ్, ఎంత రీసెర్చ్ వెళ్తుంది, ఎంత డెప్త్గా రీసెర్చ్ జరుగుతుంది, వాటి ఇంపార్టెన్స్ ఎంత ఉంది అనేది స్టూడెంట్కి తెలియాల్సిన అవసరం చాలా ఉంది. స్టూడెంట్కి లేదా అలాగే స్కాలర్స్ మెయిన్ ఏంటంటే వాళ్ళు చేస్తున్న వర్క్ ఏంటి. ఇక్కడ ఏంటంటే పీజీ ఉంది, అలాగే మాకు ఎంఎస్సీ కెమిస్ట్రీ ఉంది, సింగిల్ మేజర్ హానర్స్ ప్రోగ్రామ్స్ ఉన్నాయి. స్టూడెంట్స్ ఏంటంటే ఎప్పుడు కూడా మేము ఇందులో చేరాము లేదా ఇంకో వేరే కోర్సులో చేరలేకపోయామనే ఫీలింగ్ వద్దండి. ది బెస్ట్లోనే చేరారు, మీరు ది బెస్ట్లోనే ఉన్నారు. అలాగే ఇందులోనే మీరు హైయర్ స్టడీస్ కింద ది బెస్ట్ అవుతారు. సో అది గుర్తుపెట్టుకోండి. సో ఆ ఎంకరేజ్మెంట్ అలాగే ఆ నాలెడ్జ్ మీకు ఇవ్వడం కోసమని మేము ఈ 2 days ఇక్కడ మేము ఈ కాన్ఫరెన్స్ అనేది కండక్ట్ చేయడం జరిగింది. సో అది ఫ్రూట్ఫుల్ అయిందని అనుకుంటున్నాను. ఆఫ్టర్ దీస్ 2 days మీరు కంక్లూజన్కి వచ్చే ఉంటారు ఎలాంటి లైఫ్ ఉంది సైన్స్లో కూడా, ఎంతవరకు మనం ముందుకు వెళ్ళొచ్చు. మంచి మంచి పర్సనాలిటీస్ వచ్చారు. నిన్న మనకి బిఎల్వి ప్రసాద్ గారు అంటే ఏంటి, ఆయన ఇండియా లెవెల్లో సెంటర్ ఫర్ నానో అండ్ సాఫ్ట్ మ్యాటర్ సైన్సెస్కి డైరెక్టర్ అండి. ఎలా అయ్యారు? త్రూ ఎంఎస్సీ కెమిస్ట్రీ. అలాగే ఈశ్వర్ ప్రసాద్ గారు వచ్చేదన్నా, ఆయన ఎక్స్ డైరెక్టర్ డిఆర్డిఓ. సో త్రూ మెటీరియల్ సైన్స్, ఫిజిక్స్ అంటే ఏంటి, వీటిలోనే మనకి ఇలాంటి పొజిషన్స్ కూడా వెళ్ళొచ్చు. మీరు చేస్తున్న దానిలోనే మనం మంచిగా చదువుకొని ముందుకు మంచిగా వెళ్ళొచ్చండి. సో ఆ ఎంకరేజ్మెంట్ లేదా ఆ ఇంట్రెస్ట్ అనేది మీరు క్రియేట్ చేయడం కోసం ఈ కాన్ఫరెన్స్ కండక్ట్ చేశాము. అది ఈ 2 daysలో ఫుల్ఫిల్ అయ్యిందని నేను అనుకుంటున్నాను. థ్యాంక్ యూ అనండి. Now I invite our Administrative Officer Dr. V. Narayan Rao garu to speak few words on this occasion.
Good evening all of you. Most respected and eminent guests and dignitaries and dais, our dear Principal Madam, Professor, very eminent professor across the globe, I have to tell it, underlining it, Professor Y. Srinivasa Rao garu, and my dear colleague friends who are sitting in front of me, and then very happy to see you all, my dear student friends. Just now I came to know, Principal Madam has told, sir, extraordinary students, excellent students like Kohinoor Diamonds have attended for this 2-day international conference from topmost universities and topmost colleges in and around Vijayawada city. Definitely we are lucky enough to have your presence, my dear student friends and participant friends, because of your great presence. And Madam also told you, though I belongs to Commerce and Management, I have interacted with your resource persons yesterday and today itself, like B.M. Prasad garu, Ishwara Prasad garu, and Subramanian garu. Just before coming to this session, I also interacted with a great expert, eminent resource person, Y. Srinivasa Rao garu. Really, we are thankful to them, and definitely these 4 people belongs to our Telugu region, combined Andhra Pradesh. That is the greatness. వాళ్ళు తెలుగు యొక్క గొప్పతనాన్ని, ఆంధ్ర రాష్ట్రం, కంబైన్ ఆంధ్ర రాష్ట్రం యొక్క గొప్పతనాన్ని ఇండియాలోనే కాకుండా
ప్రపంచం మొత్తం కూడా మన తెలుగు జెండాని రెపరెపలాడించే గొప్ప సైంటిస్టులను కలుసుకోవటం జరిగింది. నాకు చాలా చాలా హ్యాపీగా ఉంది. నేను కూడా మరి ఎంకామ్కి పిహెచ్డి అటువైపు పోకుండా కెమిస్ట్రీ చదువుకుంటే బాగుండేమో, సారోళ్ళలాగా ఏమైనా అయ్యేవాడినేమో అని రియల్గా అనిపించింది. మేడం చెప్పినట్టుగా నాట్ ఓన్లీ ఇన్ కంప్యూటర్స్ you can reach a top position across the country India, across the globe, like Srinivas Rao garu, B.L. Prasad garu and other dignitaries and resource persons who have come over here and interacted with you, my dear student friends. కెమిస్ట్రీలో బ్రహ్మాండమైన ఆఫర్స్. నేను ఇప్పటి వరకు ఏంటంటే మామూలుగా ఈ ఫార్మా రంగంలోనే కెమిస్ట్రీ వాళ్ళకి బాగా బ్రైట్ ఫ్యూచర్ ఉంటుందని అనుకుంటూ వచ్చాను. అసలు రీసెర్చ్ సైడ్ కానీ మరి ఈ అన్ని విషయాల్లో కూడా మీ అందరికీ కూడా నానో టెక్నాలజీ అని కానీ ఇలాగే ఇక్కడ ఉన్నటువంటి స్మార్ట్ మెటీరియల్స్ కొద్దిగా నేను కూడా తెలుసుకున్నాను. ఆ స్మార్ట్ మెటీరియల్స్ ఇంపార్టెన్స్ అనేది నిత్యం మనం వాడేటువంటి ఫోన్ దగ్గర నుంచి ఈ మైక్రో చిప్స్ కానీ ఇవన్నీ కూడా యూటిలిటీలో మనం ఉన్నాం, కానీ అది స్మార్ట్ మెటీరియల్స్ వల్ల అవుతుంది అనే విషయం నాలాంటి ఈ సైన్సెస్లో లేమేన్కి తెలియదు. మరి మీరు ఎక్స్ట్రాడినరీ ఎలివేటెడ్ పర్సన్స్ కనుక ఈ 2 days కూడా బ్రహ్మాండంగా ఇంటరాక్ట్ అయ్యారు అనేది కూడా మాకు రిపోర్ట్స్ వచ్చాయి. మరి ఏమంటే ఎప్పుడైనా సరే మనం చెప్పడం ఈజీ, కానీ కూర్చుని వినాలంటే అది కూడా 1 hour అంటే మీకు ఓకే, 2 hours ఓకే, డే లాంగ్ అంటే ఎక్స్ట్రాడినరీ డిఫికల్ట్ టు యూ ఆల్, నో డౌట్ ఎట్ ఆల్. ఈవెన్ దెన్ విత్ లాట్ ఆఫ్ సపోర్ట్ అండ్ పేషెన్స్ యూ హ్యావ్ extended your support and interaction to the great resource persons. Thereby you have proved you are also great scholars, my dear participant friends. Thank you very much for your active participation. I also extend thanks to your faculty members, management members, university authorities, college authorities for sending you all great people to assemble here to see you all. Once again, I feel very, very happy. Thank you very much, all of you.
Thank you, sir. Now I invite convener of this program, Dr. V. Ravikumar, sir, to present brief report of the conference.
Good evening to all of you. Warmest thanks to the management, behalf of K.B.N. College, Secretary and Correspondent Dr. T. Srinivas garu, Administrative Officer Dr. V. Narayan Rao garu, SKPE Group of Institutions, Vice Principals of K.B.N. College, and Principal Dr. G. Krishnaveni garu, who are motivated and continuously supported to conducting this 2 days international conference. Thank you very much, ma'am. And also I thanks to the Dr. K.B.N. garu, Organizing Secretary, and the heads of the departments, Physics and Electronics and Chemistry departments. And also greatest honor to today's session chief guest, Professor Y. Srinivas Rao garu. Thanks to sir. So the past 2 days of this conference give many more of the ideas about the research, and also sharing their ideas, and also what the applications we are knowing in future generations of smart materials. So I think so in front of students, all of you maybe gather this information and make this event as successful. Thanks to one and all. And also a great thanks to the eminent professors, Professor B.L.V. Prasad Garu, Director of the Center of Nano and Soft Matter Sciences, Bangalore, and Professor N. Iswar Prasad Garu, Director R&D, MGIT and CBS Hyderabad, Dr. Luka Pavic, Senior Research Associate, Rudar Baskovic Institute of Croatia, Professor C. Subramanian Garu, IIT Hyderabad, and Professor M.G. Brick from Estonia, and Professor Michael Piaski. So there is no time scheduled. Actually, sir was very poor outside. It was very urgency. So after that, my warmest honorable to the Professor Y. Srinivas Rao Garu, so today's guest. So thank you very much, sir. And thanks to the participants and students and research scholars. So thank you very much. And this program was successfully completed. And also, I think we are also gathered more information regarding the smart materials. So thank you very much. So thank you, patience here.
Now I invite today's chief guest, Professor Y. Srinivas Rao Garu, to deliver a few remarks regarding this program, sir.
Good evening, respected dignitaries on the dais, of the dais. It's my honor and privilege I am here, and particularly the conference title itself, such a beautiful title, like I presented in my presentation, why it is so important, particularly coming 15-20 years. Let me congratulate the management and the organizers for organizing this 2 days event. I know I keep on interacting with Ravi sir last 2 months. Lot of pains in organizing an event. For a lot of planning, lot of coordination is required. Lot of energy goes in organizing the event. But what is the purpose of calling the scholars across the globe to your institute, to the platform? Why do we take a lot of pains in doing this? Almost 100 students might have attended this conference. How many of you are serious? We are not bothered. But I am telling you, even 1 out of 100 students is motivated, we are done. I am telling you the power of even 1 student out of 100, not immediately, in future, in your career. You thought today that you are inspired, motivated, for a period of time you have done something. I am sure you would appreciate that I attended, I was motivated that time. I don't give various examples, I will give my own example. I joined Sardar Patel in 2000. Earlier I was at Shirdi, 8 years I was working there. I shifted to Mumbai. I was the one of the starting fellow who started that institute. Our first batch student, Rahul Chari, is passed out, first batch, IT student. After passing out, right, he went to USA, he did job, he came back somewhere in 2010 or 12. Then he said, sir, I have done enough in USA, I'm not interested in doing those repeated jobs. No, I want to do something. Highly paid job, Cisco, he left, both the classmates, Rahul Chari and Samir Nigam. They came back and saying that, sir, we want to start some company. We have some idea, but no, those days, no, this startup culture is not there. Ecosystem is not ready from Government of India. They came to our college, sir, can you provide some space? They are rich people. If they want, they can hire a space in Bandra Kurla complex. But they said, no, we want to work in the college only. We were wondering, what do you get in the college? Even we do not have proper tiles also. We are under construction that time. We have provided some space in the laboratory. Okay, one fan, not even AC, one fan, one table you had given, do whatever you want. And then one day I asked him, why you came here? No, there's no beautiful infrastructure. Sir, the purpose of coming back to the college is we will get the brightest of the bright students who will work on our project. Right? Internship. And they're paying also. Though they are not earning, they're paying also some stipend. And what is the advantage of working with the student? Do you know? No timing. If I employ you, sir, 5 o'clock ho gaya. I want to go home. How much have you paying extra if I want to work more? No, I have family. So many things will come into picture. But if I pay peanuts to a student, raat ko, even 10 o'clock is over, no, sir, we want to still work. Or we will sleep in the lab only. That's the beauty of the students. And 1 year they have worked, they developed one product. They were unable to sell it. It's a flop. They could not make money and nobody is buying. Do you know what was the product? Audio streaming. Audio streaming means now it is popular that pay money to listen a song that some company has come. Spotify or something like that. Time they developed, but nobody was purchasing their product. And I asked them, what happened? No, sir, nothing. Then one day he said, sir, we are patenting our work. Oh, where? How much? We were not doing that all those procedures in 2010. Sir, we will do in US patent, not India. He said, how much it will cost? That time he was at 30 lakhs. And you are spending 30 lakhs. Yes, sir, it is worth to do patent in USA, not in India, because it is in dollars. And their geographical location is much more richer than Indian patents. They patented, they came back. But then one day they said, sir, we are leaving the campus. I said, what happened? Flipkart has purchased our product. How much? No, they are not giving any money. They said, whatever is that product is okay, but you please join our company. Our entire team, that's the condition, entire team, because they liked the people who have worked for a project. Forget about the product. The culture they have developed. They want that entire team to be. Then I said, any money you got? Because we also expecting something they will give. They said, no, we didn't get any money. We got shares. Flipkart shares, they have got it. They joined the company. And both the people, Samir Nigam and Rahul Chari. Have you heard about these two names any time? You didn't. Okay. But you are using, every one of you are using this product. More in Andhra Pradesh than in Maharashtra, anyhow. Then, they joined Flipkart. One day, they said, sir, we want to recruit the students in our company. They came back to SPIT. How much you will pay to students? Sir, 40 lakhs to each student. How many students you want? We want 10 students. Can you imagine? They started another company. And what is that company? A app. They developed a app because they have, while working in that Flipkart, they felt boring. Nothing is there. So they quit that company, developed one product. What is that product? They understood that in the Flipkart there is a problem. The problem is when the Flipkart started, they were selling the books. And do you know how they are selling the books? Cash on delivery. Because Indians are not believing, if you pay in advance whether the product will come or not. So cash on delivery, that was their product. And but then what is the headache there? Collection of the money. Entire country, how to collect the money. Such a risky business, the centers, everything. So they understood there is a problem here. And that problem is their solution, their product. And they made cashless UPI. Now so many UPSs came. That name of the company is PhonePe, is our students. Do you know what is the worth of that company? Maybe $1 billion. $1 billion company. Internationally, they have international branches also. And per student, they are paying 40 lakhs starting salary. My salary is not that much. Understand the power of technology. And another beauty thing happened. It happens only in few IITs, but this year it has happened. He came to SPIT, said, "Sir, this institute is developing. I want to donate some money. How much money you want?" We said, "How much money?" "Give some money." He said, "Okay, $1 million we are donating." Equivalent to around 8.5 crores, they have donated just like that. One check. One student. How many students are passed out? It's okay. He set an example. Now other students are coming. "Sir, we want to donate. Can you, what do you want?" So what we want is a proposal, not money. If I have a proposal, they are willing to invest. Anyhow, what I'm trying to say is that is the power of mass education. If I am teaching to 100 students, even one student is enlightened, motivated, God knows he will employ all 100 students. So believe in yourself, please. That's what I'm trying to say wherever I was invited. I ask only few questions, not the answers. What we were before Britishers ruled. Just verify what we were. India's GDP was 30% of the world's GDP before Britishers ruled this country. World's 30% GDP was in India. Before Britishers, 1 rupee is equivalent to $1. Before Britishers, Indian education is above 90% literate, entire country. After Britishers left, it is less than 10%. They literally made us as a slaves, labor. They never ever wants us to develop. They never ever wants to think, design. They want only a cheap labor. The education system, the way they develop in such a way that you always seek a job, not a creator. You are a labor. All top posts are Britishers and they employ the labor. That means they are only degree awarding institute where you will become a clerk, not the designer and developer. And we continued, even Britishers left 75 years. We need to change. That's why Government of India is bringing this national education policy, started saying that believe in yourself and be a creators, designers and developers, not the cheap labor. And you go any country, top most CEOs are Indians. You name a company, multinational companies, all CEOs are Indians. Please understand this. Believe in that. Even Britishers ruled us 200 years. Now Indian has ruled Britishers few years back. Rishi Sunak. That's the example we have set. So be confident and, as I said, concluding, do it yourself. Do it yourself. Thank you.
Now I call upon Mr. Prakash to take over the session to organize prize distribution as well as certificate distribution.
Poster presentation. First prize goes to M. Sri Trisha from First BSc Biotechnology. prize goes to P. Nagasailaya from SRM University. Third prize goes to V. Dhanush from 2nd BSc Electronics. Consolation prize goes to Zeba from 2nd BSc Biotechnology.
Now we move on to the other special event of this event, certificate distribution. I invite Y. Gandhi, K. Venkatratnam College to come onto the dais. P. Rajnikant, K. Venkatratnam College to come on to the dais and take your certificate. Rajnikant. T. Narendrudu, Aditya University. T. Uma Maheshwar Rao, Hindu College, Guntur. Sajini from Krishna University. D. Rajeshwari, NIT Warangal. Ms. D. Swati Rohita from NIT Warangal. Ms. M. Hemalata, SRM University. Mr. Akshay Uttam from SRM University. Akshay Uttam from SRM University. Miss L.N.S. Laya from SRM University, AP. Mr. T. Uday Kiran from K.B.N. College. Uday Kiran. Mr. P. Falgun Kumar from K.B.N. College. Mr. V. Chanakya from K.B.N. College. Mr. P. Durga Ganesh from K.B.N. College. P. Durga Ganesh. So if anyone is interested to give their feedback regarding this 2-day international conference, can come forward.
Not interested. It is compulsory, mandatory, 2 girls and 2 boys. Otherwise, 3 girls, 2 boys.
Good afternoon, everyone. I am Mohammed Zabatan, second year of BS Technology, K.B.N. College. So firstly, I'd like to say that it's definitely an honor to come up here and stand in front of all of you and to say a few words. First and foremost, I'd like to thank our respected dignitaries who made up time and came here to give us their valuable knowledge, who has shared their wealth of knowledge to us. Everyone, including Prasad sir, including Ishwar sir, Srinivas sir, and of course the foreign professors. I heartfeltly thank all of them. And I really thank, a very special thanks I must say, to the chemistry department, to the electronic and physics department for organizing the conference. And definitely I would definitely thank Kiran sir, Vijay Bhaskar sir and Swati ma'am, who has been guiding us 24/7 for the poster presentations and all our presentations. And lastly, I'd like to thank all of you, to all the participants who has made this event a grand success. Last, I would definitely say, Srinivas sir, your words saying believe in yourself and do it all yourself, these are some things everyone, including me, are going to remember forever. And lastly, thank you so much.
Congratulations. Good. Another girl students expecting from SRM University. Good. Previously K.B.N. brand.
Good evening, one and all. First, I would like to thanks Dr. Krishnaveni madam. BSc అయిపోయింది, తర్వాత ఏం చేయాలి అని చెప్పి జాబ్కి వెళ్ళిపోయాను. వెనక్కి పిలిపించి మరీ ఎంఎస్సి కంప్లీట్ చేయించారు మేడం. ఆఫ్టర్ ఎంఎస్సి క్వశ్చన్ మార్క్ అయిపోయింది. నెక్స్ట్ ఏం చేయాలి, ఫార్మా సైడా, ఎక్స్పెరిమెంట్స్ తెలీదు, ప్రాక్టికల్స్ రావు, హ్యాండిలింగ్ రాదు, ఏంటి అని ఆలోచిస్తే పిహెచ్డి. సో ఫస్ట్ థ్యాంక్ యూ మేడం. ఒక చిన్న స్టేజ్ నుంచి పిహెచ్డీలో ఎస్ఆర్ఎం నుంచి పిహెచ్డీ నుంచి లయ వచ్చింది, లేదా మన కేబిఎన్ అమ్మాయి ఎస్ఆర్ఎం నుంచి వచ్చిందని చెప్తున్నారు. సో ఫస్ట్ ఆ మాటకి చాలా థ్యాంక్ యూ. మీరు లేకపోతే ఈ ఫేమ్ నాకు వచ్చేది కాదు, ఫస్ట్ థింగ్. అండ్ నెక్స్ట్ ఎస్ఆర్ఎం యూనివర్సిటీ వాళ్ళకి థ్యాంక్స్ చెప్తున్నాను. ఇక్కడ దాకా నన్ను పంపించి 2 days నన్ను ఈ కాన్ఫరెన్స్కి అటెండ్ చేసేలా చేశారు. అండ్ ఈ 2 days ఇంటర్నేషనల్ కాన్ఫరెన్స్లో మీరు అనుకుని ఉండొచ్చు మీ బీఎస్సీ ఎంఎస్సీ లెవెల్కి ఇదేం అర్థం కాదు. ఖచ్చితంగా చెప్తున్నాను, ఈ కాన్ఫరెన్స్ ఏదో అటెండ్ అవ్వాలి, బలవంతం చేసి కూర్చోబెట్టేశారు, ఇదంతా సెకండరీ. బట్ చాలా నాలెడ్జ్ ఉంది. యాజ్ ఎంఎస్సీ అయిపోయి బయటికి వెళ్ళాక మీకు అర్థమవుతుంది ఫ్యూచర్ స్కోప్ ఎక్కడుంది అని. అండ్ ఈరోజు సెక్షన్లో ప్రొఫెసర్ వై శ్రీనివాసరావు సార్ చెప్పింది మోస్ట్లీ ఏఐ, ఖచ్చితంగా ఏఐ పర్సన్స్ని రీప్లేస్ చేస్తుంది. ఇది పిహెచ్డీకి వెళ్ళాక నాకు తెలిసింది ChatGPT అనేది ఒకటి ఉంది, దాని నుంచి పేపర్స్ కూడా రాస్తున్నారు అని 6 monthsలో నేను తెలుసుకున్నాను. కానీ ఇప్పుడు ఆ ఏఐ కూడా ఒక పర్సన్ని తీసేసి అదే వర్క్ మొత్తం చేస్తుందని చెప్పి ఒక టాక్ అనేది వచ్చేసింది. ఇప్పుడు ఈ 5 yearsలో ఇంత డెవలప్ అయిందంటే ఇమాజిన్ ఒక 10-15 yearsలో ఒక మనిషి వర్క్ చేయకుండానే మొత్తం కంప్యూటర్ చేసేసిందంటే మన రోల్ ఇలా ఉంటుంది. ఎంఎస్సీలు చేసి పిహెచ్డీలు చేసి మనం ఏం చేయలేము. సో ఈరోజు సార్ ఎక్స్ప్లెయిన్ చేశారు, ఏఐ లేకుండా కూడా కొన్ని సెక్టర్స్ మనుషుల వల్లనే పనిచేస్తాయి, ఆ సెక్టర్స్కి మ్యాన్ పవర్ ఖచ్చితంగా యూజ్ అవుతుంది. సో ఈ కాన్ఫరెన్స్కి రాకపోతే నాకు ఈ విషయం తెలిసేది కాదేమో. So thank you K.B.N and thank you SRM University for giving this great opportunity from bottom of the heart. I'm thanking one and all.
చలి రారా మీ మేడం గారితో గుడ్ కంగ్రాట్స్. బాయ్స్ సైడ్ very good. Good.
Good afternoon everyone, respected sirs and guests. My name is K.B.N from 2nd BSc Computer Science. First of all, thank you so much sir for this conducting topic, functional and smart materials. చాలా మందికి తర్వాత గ్రాడ్యుయేషన్ అయిపోయిన తర్వాత ఏం చేయాలనేది ఏం తెలియదు సార్. ఈ యొక్క టాపిక్ వల్ల, ఈ కాన్ఫరెన్స్ వల్ల జాబ్స్ ఏంటి, దాని యొక్క ఆపర్చునిటీస్ ఏంటి అనేది చాలామందికి తెలిసింది సార్. అండ్ అలాగే ఇక్కడికి వచ్చినటువంటి గెస్టులు కూడా వాళ్ళ యొక్క పర్సనల్ ఎక్స్పీరియన్స్ని అండ్ ఫిజిక్స్ అండ్ కెమిస్ట్రీ, ఎలక్ట్రానిక్స్ యొక్క ప్రాధాన్యత ఏంటి, దాని యొక్క వాల్యూ ఏంటి అనేది తెలియజేయడం అనేది జరిగింది. నౌడేస్లో చాలామందికి ఫిజిక్స్ అండ్ ఎలక్ట్రానిక్స్ అండ్ కెమిస్ట్రీ అనేది ఒక సబ్జెక్ట్లా అనుకుంటారు, కానీ వాటిలోనే ఎన్నో అద్భుతాలు అనేవి ఉన్నాయి. ఎక్స్పీరియన్స్ అంటే ఈ కాన్ఫరెన్స్ అనేది పీజీ లెవెల్లో ఉంటుందని అన్నాను, కానీ దీన్ని డిగ్రీ లెవెల్లో కూడా కండక్ట్ చేసినందుకు థ్యాంక్ యూ సో మచ్ సార్. అండ్ అలాగే దీనికి నేను అటెండ్ అయినందుకు చాలా అదృష్టంగా భావిస్తున్నాను. అండ్ థ్యాంక్ యూ సో మచ్ సార్ ఫర్ దిస్.
నేను ఒకసారి ఇలా మీ సార్ రవికుమార్ గారు వెయిట్ చేస్తారు. గుడ్. నేను ఇంకెవరైనా మగపిల్లలు ఒకడన్నా వస్తే బాగుంటుంది కదా. వెనకాల ఎస్ఆర్ఎం యూనివర్సిటీ నుంచి ఫ్రెండ్స్ చాలామంది హుషారుగా ఉన్నారు, వాళ్ళు ఎవరైనా రావాలి.
ఓకే,
Good evening one and all. Respected sir, madams, everyone, good evening. So conference was too good. ఆల్రెడీ K.B.N గురించి తెలిసిందే, ఇలాంటి కాన్ఫరెన్స్లు చాలా ఆర్గనైజ్ చేశారు. ఇప్పుడు ఆర్గనైజింగ్ కమిటీ కెమిస్ట్రీ డిపార్ట్మెంట్ అండ్ ఫిజిక్స్ ఎలక్ట్రానిక్స్ చాలా మంచిగా ఆర్గనైజ్ చేశారు. కొన్ని టాపిక్స్ మన రీసెర్చ్ వర్క్కి రిలేటెడ్ కాకపోయినా మిగిలిన టాపిక్స్ ఫంక్షనల్ మెటీరియల్స్, ప్రాపర్టీస్ ఆఫ్ దోస్ మెటీరియల్స్, థియరిటికల్ డిజైన్ ఆఫ్ ఆప్టికల్ ప్రాపర్టీస్, ఆ టాపిక్స్ నా రీసెర్చ్ వర్క్లో చాలా హెల్ప్ అవుతాయి. సో థ్యాంక్ యూ ఎవ్రీవన్. థ్యాంక్ యూ.
మళ్ళీ మీ పేరు, మీ ఊరు అన్నీ చెప్పలేదు. వేర్ ఫ్రమ్ యూ కేమ్ అనేది చెప్పరా? ఫస్ట్ ఇంట్రడ్యూస్ యువర్ సెల్ఫ్.
Myself Hemalata. I am research scholar under the guidance of Dr. Mahesh Kumar Rava. I am from SRM University.
Excellent.
Ex-chemistry lecturer of K.B.N College.
అది చెప్పారు. అలా అయితే మీకు ఫేవరెట్ ఎవరు? ఆ శైలజ మేడం ఫేవరెటేనా?
అందరూ మా డిపార్ట్మెంట్ అందరూ సార్.
శైలజ నువ్వు రారా తల్లి. మధ్యలో రండి. ఒక్కళ్ళు ఎవరన్నా బాయ్స్ సైడ్ నుంచి ఒక లిస్ట్ క్లోజ్ చేద్దాం. ప్రకాష్ ఎవరు ఉన్నారు నాన్న? మీ ఫేవరెట్ స్టూడెంట్స్ ఎవరు ఉన్నారా? వచ్చాడు అయిపోయాడు. రవి ఎవరైనా ఉన్నారా? ఎంఎస్సీ పిల్లలు మా కృష్ణవేణి ఎంఎస్సీ పిల్లలు మగ పిల్లలు ఎవరు లేరు?
Second BSc Physics, Manoj, come. This one is the opportunity to express yourself. So this type of stages will not come in future, I think.
This is Manoj from second BSc Physics. First of all, I'm very thankful for management. Functional and smart materials అనేవి కాన్ఫరెన్స్ అనేది K.B.N కాలేజ్లో మా డిగ్రీ లెవెల్లో కండక్ట్ చేసి దీని మీద ఈ టాపిక్ మీద ఒక అవగాహన తీసుకొచ్చారు. సో ఈరోజు శ్రీనివాసరావు సార్ చెప్పిన టాపిక్ మీద ఒక అవగాహన అయితే వచ్చింది. సో బీఎస్సీ తర్వాత ఏం చేయాలి ఏంటని ఈ అండర్ గ్రాడ్యుయేషన్ తర్వాత ఏం చేయాలి ఏంటి అనేది తెలియదు. సో ఈ అండర్ గ్రాడ్యుయేషన్ తర్వాత ఏం చేయాలి అనేది ఈరోజు సార్ చెప్పిన టాపిక్ మీద అయితే ఒక అవగాహన అయితే ఉంది. సో దీనివల్ల చాలా ఎక్స్పీరియన్స్ వచ్చింది. ఈరోజు నిన్న కానీ ఈరోజు కానీ కాన్ఫరెన్స్లో నానో టెక్నాలజీ మీద, ఫంక్షన్స్ అండ్ స్మార్ట్ మెటీరియల్స్ కాన్ఫరెన్స్ మీద చాలా నేర్చుకున్నాము. సో కాన్ఫరెన్స్లో ఆ వీడియో కాల్లో ప్రొఫెసర్స్ కానీ ఈరోజు మరి స్టేజ్ మీద చెప్పిన శ్రీనివాసరావు గారు సార్ కానీ ఈ నానో టెక్నాలజీ మీద మొత్తం మీద పూర్తి అవగాహన ఉంది నాకైతే. సో అండర్ గ్రాడ్యుయేషన్ తర్వాత బెస్ట్ ఆపర్చునిటీస్ ఉన్నాయని ఈరోజే తెలుసుకున్నాను. సో అండర్ గ్రాడ్యుయేషన్ తర్వాత ఏం చేయాలి అనేది ఒకసారి ఆలోచించుకొని మరి అందరూ కూడా అవగాహన తెచ్చుకొని ఒకసారి అందరూ కూడా ఆలోచించుకోండి. ఒకసారి అండర్ గ్రాడ్యుయేషన్ తర్వాత అందరూ ఆలోచించుకొని మరి సరే ఓకే, థ్యాంక్ యూ సో మచ్.
Now it's time to felicitate today's guest. So I request our administrative officer to felicitate today's guest. Please arrange for felicitation. All the faculty of Physics, Chemistry and Electronics to come on to the dais to join in the felicitation. Now I invite Dr. O. Sailiza, Head Department of Chemistry, to express formal vote of thanks. Esteemed dignitaries, distinguished guests, respected faculty members, dear participants and students. As we come to the conclusion of this remarkable two-day international conference on functional and smart materials organized by the Department of Physics, Chemistry and Electronics in collaboration with the APSHE, I stand before you with immense gratitude and appreciation. First and forward, I would like to extend my heartfelt thanks to the chief guest, Professor Y. Srinivasrao Sir, Department of Electronics and Telecommunication Engineering, Dr. Sardar Patel Institute of Technology, Mumbai. Sir, your presence here today has truly added immense value for this conference. A special thanks to Dr. T. Srinivas Garu, Secretary and Correspondent, and V. Narayan Rao Saru, Administrative Officer, SKPVB Group of Institutions. Your unwavering support has been a vital role in this conference. And would like to thank to Dr. G. Krishnaveni Ma'am, Principal of K.B.N. College, for gracing us with your presence and support. And I would like to acknowledge the presence of Vice Principals, K.B.N. College, Sri P. L. Ramesh Garu, Dr. N. Venkateswara Sir, and Dr. K. Ramakrishna Sir. And our sincere thanks to the organizers of this secretary, organizing of this conference, Dr. V. Ravikumar Sir and Dr. K. Kiran Kumar Sir, for your tireless efforts for this conference. And special thanks to the Faculty of Physics, Chemistry, Electronics for their dedicated efforts in organizing this conference. And I would like to take opportunity to express my deepest gratitude to Executive Officer M. Srinivas Sir, whose constant support and encouragement made everything possible. And we also great deal with print and electronic media and non-teaching staff. Last but not least, I would like to thank all the participants, students and attendees for your enthusiastic involvement, active engagement and contributions. Thank you. Let us stand for national anthem.
पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे